Welcome to Go Get It. Today we are going to see another important graph search algorithm, that is breadth first search. To know breadth first search, one should be well versed with the data structure called as queue and its relevant operations enqueue and dequeue. We have a queue which is empty queue mentioned on the right hand side of the screen. We'll use this queue to keep track of all the unvisited nodes of a currently working node. Now in this breadth first search, we have a concept called currently working node. Let's start our discussion with node A. We'll add it to the output sequence first and we'll mark it as visited. And this will be our first currently working node, which is denoted by this red arrow. Now, as per breadth first search, we have to check all the adjacent unvisited nodes of the currently working node. Now we have B and S here. So we'll enqueue B and S alphabetically. So we'll enqueue B first and we'll add it to the sequence. Similarly, and we'll mark it as visited. Similarly with the S, we'll enqueue it and we'll mark it as visited, adding it to the sequence. And that's it. For node A, we have only B and S as adjacent nodes. Now we have to update the currently working node. So we have to check first of all the first element of the queue. We have B here. So we'll update the currently working node pointing to B and dequeue B. Now we see that B has only A as a current node, adjacent node, which is visited already. So we have to update again the currently working node based on the top symbol of the queue. So we'll update pointer to point to S and we'll dequeue S. Now S has C and G as adjacent unvisited nodes. So alphabetically we'll enqueue C first and add it to the sequence. Mark it as visited. We'll enqueue G and adding it to the sequence, marking it as visited. S has A, C and G, which are all visited, so we'll update the pointer based on the top symbol of the queue. So we'll update the pointer to C as a currently working node and we'll dequeue C. C has D, E and F as currently adjacent and unvisited nodes, so we'll enqueue D, E and F. We'll enqueue D, adding it to the sequence. Similarly with E and simultaneously marking it as visited. Enqueue F, marking it as visited and adding it to the sequence. So this is the time now when we have to update the pointer. We have G at the top of the queue. We'll update the pointer to point to G and we'll pop it off. Now we have G here. G has only H as the adjacent unvisited node. We'll enqueue it and we'll add it to the sequence and marking it as visited. Now we have D as the top symbol of the queue. We'll dequeue it and we'll point it to D. D has C already visited, so update the pointer to point to top symbol of the queue, that is E, and dequeue it. E has all the nodes visited, so update the pointer to point to F and dequeue. Similarly is the case with H, last symbol of the queue. We'll dequeue it and we'll point H. H doesn't have any other node which is unvisited and adjacent. That's it. We are done. Queue is empty. This operation signals the algorithm to stop. This is how breadth first search works, and you can see the output produced at the screen below. To know about depth first search technique, please visit the link mentioned below in this video.